how's it going? Everyone loves drawing circles, right? Or maybe not. Anyways, today we're making some. So for our first circle, we're gonna use a compass. A compass is pretty easy to use. We just place it anywhere we want.
And now we just need to rotate it, and we can know where the center is because the compass has a little mark right in the middle.
But what if we didn't have a compass? We can still make our circle. We just need something circle we have at home. It can be a toilet paper roll or a lid, which is bigger. We just place it right there, and now we just need to trace it. But now, how do we know where the center is? We can use Thales' theorem. To apply Thales' theorem, you only need a 90-degree angle. This is a pretty good 90-degree angle.
First, we need to place the vertex of the 90-degree angle right on the circumference, and we trace a rays and make it up. Now, Thales' theorem tells us that these 2 points, where the rays come into contact with the circumference, will be diametrically opposed, meaning they're opposite ends of a diameter. So if we join them, we'll get, boom, a diameter. And what if we repeat the process again on the other side of the circle? We can get another diameter, and where 2 diameters meet will be the center. And now we have found the center, Thales' theorem.
But why does Thales' theorem work?
First, we have to take a look at these 2 parallel lines intersected by a transversal. If we call this angle A, then this will also be angle A because they are alternating interior angles. And if we had another transversal right here, and we call this angle B, this will also be angle B because again they're alternating interior angles. And we can call the last angle angle C. And here we have a straight line. So we can say that A plus B plus C equals 180 degrees. And what do we have inside this triangle A, B, and C? So the angles inside the triangle add up to 180 degrees. We also need to learn about the socialist triangle theorem that tells us that in a socialist triangle where this side equals this side, the angles opposite to these 2 sides will be equal to each other, or congruent.
We're ready to prove Thales' theorem.
Here we have a circle with center O, and we have drawn 3 radiuses. And remember that all radiuses measure the same. So if we join point A and C, we can get a small isosceles triangle made up of 2 radiuses. And if we join C and B, we get another isosceles triangle. And remember that we learned about the isosceles triangle theorem. So in this triangle, if we call this angle A, then it will also be angle A because they're the angles opposite to the congruent sides. And if we call this angle B, then it will also be angle B, angles opposite to the congruent sides again. And we also learned that the angles inside the triangle add up to 180 degrees. So in this triangle, triangle ABC, we can say that A plus B plus B equal 180 degrees. That will be 2A plus 2B equal 180 degrees. Dividing by 2, A plus B equal 90 degrees. So this angle, angle C right here, A plus B, will be a 90-degree angle, a straight angle. A straight angle, rays extended. The points where these rays contact the circumference will be diametrically opposed, or opposite ends of a diameter AB. Thales' theorem.
Now we have learned about Thales' theorem. Thanks for watching.